All right, again in lesson 17, we've got that long title that basically is introducing us to slope-intercept form. You know, the line joining two distinct points of the graph of y equals mx plus b has slope m. Okay, let's break it down here. Slope-intercept form, y equals m times whatever x is plus b. Now, x and y, these are just our input-outputs in our excuse me, input-output table, right? They're points on the graph. We can pick x values and get y values out. What we're concerned with here is our m and our b. The number attached to the x, the coefficient, that is our slope. We don't have to figure it out. We don't have to do rise over run. We don't have to do the slope formula if it's written in this form. Whatever number is a coefficient of x is the slope of the line. Slope-intercept form also says whatever is being added on, okay? Even if it was b plus mx, okay? Whatever is added on is the y-intercept. And I'm going to try to spell it better this time. The y-intercept. So let's talk about what does a y-intercept mean. A y-intercept is where your graph, your line will hit the y-axis. And we're going to focus more on that when we get into graphing, okay? But this is a really, really, really powerful form, okay? And you're going to use it over and over as you move up in math, especially in any graphing when it involves algebra. And it's actually a shortcut way. We'll get there. So let me show you what I mean here. The graph of the equation, y equals 7x. Now instead of minus 3, I'm going to keep change, or subtracting is the same thing as adding the opposite. And I'm going to go 7x plus a negative 3. What has what slope? Well, what number? This is in slope-intercept form. Y equals mx plus b. Whatever number is attached to the x, that's our slope. I don't have to do any work as long as it's in this form here. The graph of the equation, y equals a negative 3/4 times x. And again, instead of minus 3, I'm going to say plus a negative 3. What is the slope? Negative 3/4. If you understand slope-intercept form, you know what the slope is. There is no figuring it out. Slope, as we've been talking about, also comes on some like different names. Here's what I mean. You have $20 in your savings at the bank. Each week you add $2 to your savings. So every week, let y represent the total amount of money you have saved after the end of x weeks. Write an equation, identify the slope. Okay. If you're adding $2 to your savings every week, that's our rate of change. Or our unit rate. And if you remember from a previous lesson, our rate of change, our unit rate, our constant, that's the slope. So in this case right here, our slope, our m, is 2. So when we want to do a real life problem here, we want to represent the total amount of money we have. Well, I have, that's y, and it's going to equal however much money I have. I have $20, and then I'm adding $2 per week. We've been given these problems before, and we're like, hey, write an equation for them. We can do that, but we weren't thinking of it in terms of having a slope and a y-intercept. So what I want you to know is anytime you can see a rate of change or a unit rate, each week you add $2. So it's $2 per week, or for each week, or something like that. That is your slope, okay? So this 2 right here, that's our slope. Now notice, this is a little bit different, right? We have like the b plus mx. That's okay. It's always the coefficient of x. That's a slope. All right. So what happens if it's not written in slope-intercept form? And I'm going to be honest, guys. If it is not written in slope-intercept form, the slope of this is not 9. No. Because this isn't in slope-intercept form. So we can't just say it's always the coefficient of x. It's only if it is in y equals mx plus b form. Y equals a number times x plus b plus the y-intercept. Okay, so please pay very, very close attention to this part because this is the part that people tend to get wrong. They're like, oh, finding slope is easy. All you have to do is take the coefficient of x. except it has to be written in slope-intercept form. So let's practice that, okay? Notice it says here, solve the following equation for y. Yep, y equals mx plus b. So I'm going to rewrite this as, let me get rid of that line. This is going to be 9x. Instead of saying minus y, I'm going to go plus, keep, change, a negative 3y equals 15. And if I'm solving for y, this is what I want to keep. So I need to get rid of whatever's being added to or subtracted from it. 9x is being added to it, so that means I have to get rid of 9x from each side. Whatever I do to one side of the equal sign, I do the other. We've done this before. If I have 9x's and I take away 9x's, that's gone. I bring down my negative 3y's. Now, right here, you're going to notice that I wrote the 9x kind of off to the side. These aren't like terms. Do not tell me this is 6x, because it's not. This is 15 minus 9x or plus a negative 9x. Again, you could just say 15 minus 9x. That's fine too. All right, so now I've solved for the y term. I got to solve for y. I'm solving for y. It's negative 3 times y, so I want to do the inverse or the opposite. And the opposite of multiplying is dividing. And I'm going to divide both sides by a negative 3. The reason negative is negative divided by a negative is a positive y. And this over here, we've got to divide each term here by a negative 3. So I need to go 15 divided by negative 3 plus negative 9x divided by negative 3. That is going to lead us to y equals 15 divided by negative 3 is a negative 5 plus negative 9 divided by negative 3 is a positive 3. And then we have our x. This is slope-intercept form. It is solved for y. So now if I want to know what my slope is, my slope is going to be the coefficient of x. It's going to be the number attached to the x. 3, not 9. This right here, guys, is something that it's actually all that solving equation stuff that we've been doing. You know how to do it. What gets confusing is when we have these variables. So let's try one more example. Solve the following equation for y. The reason we solve it for y is because we want to put it in slope-intercept form. That's a very powerful form that we can do lots from. And it helps if you write the equation correctly. So we have 5x plus 9y equals 8. Now again, I am solving for y, so I got to get rid of whatever's attached to it. Remember we draw these lines around here? If I'm solving for this, I got to get rid of whatever's being added to it. So I'm going to subtract 5x off of each side. That gives me 0, and I can bring down my 9y equals. And again, don't put these together. It's not 3x. They're not like terms. This is 8 minus or 8 plus a negative 5x. Now this is 9 times y. Solve for 9y. Now I got to solve for y. It's 9 times y, so I'm going to do the inverse, and I'm going to divide by 9. And I'm going to be left with 9y equals, again, divide everything by 9. 8 divided by 9 plus a negative 5x divided by 9. You can make this into decimals, but honestly, you really don't have to. You can just leave it like this. And our slope is going to be whatever the coefficient of x is. So in this case, it's going to be a negative 5/9. So big takeaways. If you can write an equation, which is in, like these were in standard form, if you can solve them for y, you now have an equation written in slope-intercept form. And from slope-intercept form, we are able to quickly and easily pick out what our slope is.